Hey there. So in this video, I'm going to walk you through the exact process that you can use to carry out sales forecasting for Black Friday, Cyber Monday. At the time of making this video, it's only a couple of months away from Black Friday, and therefore it's now high time that you should be ready with all your preparations. And your preparation will definitely have to include sales predictions or forecasting. You can use any kind of forecasting model. In this video, in this exercise that I'm going to show you, I'm going to be using a machine learning model, and therefore it will involve some Python code, but there's no need to be scared because of that. I'm going to walk you through the entire process, and you can actually have this file and use it for your own purposes, and then you'll see that it's not that difficult. But you should understand the basic concept behind it. So the way we are going to do sales forecasting for Black Friday and Cyber Monday in this exercise is by using a set of data, which you can see here, a part of that. How we arrived at that, how we loaded the data into the system, what this environment is called, and all that. I'm coming to that. But before that, let's just look at the kind of data that we're working with and the kind of predictions you'll be making. So when I mean sales prediction, I basically in this case mean purchase predictions, how many purchases, and that will be on the basis of what kind of customers you're going to get, right? And that's eventually what it's all about, right? If you understand your user, if you understand your target customer, your prospect, then you will know that whether or not they're going to make a purchase. So essentially, that's the kind of prediction that's being done here. So we have got a data set which includes user ID, product ID, gender, age, occupation, city category, where they are, how many years they've been staying in that current city, the marital status, product categories that they're purchasing, and then there's also purchase. Okay, so the purchase is the value and associated with the transaction, and therefore that is at a user level. Okay, so that's as you can see, each row is corresponding to a user ID. If I actually jump into the raw data here, this is the raw data from which has actually been uploaded to that environment, which is called Google Colab, which is used for writing Python code. So this is the raw Excel file, and it is basically the same set of data. And just to show you how much data it is, it's actually a large amount of data, 55,000. And by the way, the code is not mine. The code is sort of taken from different sources, but it's not from one source. And I've sometimes improvised on that code, but it's actually available on Kaggle. And there's quite a bit of work around the data set as well by others. So neither is the data set mine, of course, 55,000 rows of data. And then the code is also sort of sourced from the internet, but I have used my own improvisations in some points, which I will point out in the course of the video. Now let us actually talk about the environment that we're going to run the code in. This is called Google Colab, and this is very commonly used for Python. There are a lot of other environments or tools that you can use to run Python code. The most common being Jupyter Notebook, but that's going to run on your system. The advantage of Google Colab is that you don't have to download anything. You can just go to colab.research.google.com, as you can see here in the URL bar, in the address bar, or you can just search Google Colab, and it's going to be taking you straight to this particular place here. Start a new notebook and start working on it. In your case, if you get my IPNB files, the IPNB file is IPNB is the extension. So if you get this file from me, you can just upload it, and it will just load the entire stuff, including the code and the output. If it doesn't have the output, then you will have to do a connect to runtime. This is the button here for that, and then you will see that you will be able to run the code one by one. So these are individually called cells. You will just have to click on each run button in each cell, and then you will get the corresponding output for the code. So that's how the system works. And now let's get, now that being said, let's just focus on the problem at hand. So we are going to try to predict purchases, right? So we're going to try to understand how much sales are going to happen. And why is it linked to Black Friday? That might be a question, right? I mean, this of course can be done. This is an exercise that can be done any time of the year. But the question of Black Friday comes into the picture because we are going to talk about specifically a data set that has been collected during last year's Black Friday. So that is the underlying assumption here. Of course, this is a test data set. You can use it for your own store, your own brand, wherever you're using it, and or for your client if you are a performance marketer, and then run this code to understand Black Friday better. The reason I'm saying that this should be on the basis of last year's Black Friday, because that's the latest data that you have, right? I mean, Black Friday only happens once a year, and so therefore the data that you can have, which is latest, will be the last year's data, and it will be the data consisting of different users. So the purchases that have been made by different users, or the users who have made purchases rather, during Black Friday is the data set that you're going to use. Okay, and that is basically going to give you a good estimation, because that is the input data that you're feeding the algorithm. That, okay, this is the profile of customers. Now on the basis of that, do all the analysis that you need to do, things like feature selection and ultimately arriving at a model and then making the prediction. So the way it works is you start with loading something called libraries. So there are different libraries that you need to load: NumPy, Pandas, Seaborn, Matplotlib, but very basic and important libraries related to data science within Python. NumPy and Pandas are going to handle the manipulation of basic things, basic aspects of the data sets, and visualization is carried out largely by Seaborn and Matplotlib. Then you also have some other parts of the code here. In fact, not all of it is required, but anyway, I mean, it has been used here, but I'm going to be actually doing it in a different way. This would be required if you were, for instance, doing it in say Jupyter Notebook, or you were trying to get the file directly from Kaggle. Like I said, the file actually exists on Kaggle, I mean the input file, but for me, obviously, I have downloaded it into my system and I'm going to upload it from there. So there you go. I'm just uploading it into Google Colab directly. And this is the syntax for it. I'm not going to walk you through all the syntaxes. This is not a Python training session. This is just to walk you through what's going on and so that you understand what's the logic behind it and you can apply it. And once it has been loaded, we are just seeing the first 5 rows. That's why it's .head. That's how it works. And then you can see the different kinds of data points that are existing. Now let's actually look at the description of the data set. And as you can see, each of the now this is an important point actually. You will have to understand each data point and the type of data that it is. For instance, if it's an integer or it's a string. Okay, so anything that's that's called object is essentially what's called a string. I hope you're aware of the word string in computer science, which means that it's non-integer or textual kind of data. So anything that's gender, obviously gender is going to be male or female and like that. And age is supposed to be an integer, right? You might be surprised that it's actually given as object here, and that's because it's given in the form of this range here, as you can see. Okay, so that's kind of like masking probably, just to give an idea or maybe just to classify. That's how the data has been made. I mean, you don't know as an analyst, you will not always understand how the data exists, but in your case, you will be downloading your own data. So most likely, most likelihood, you will not have it in the form of classes of data. This is basically called class data, but you will not have class data like this. You will probably have individual data points for age, and then you will have age as an integer as well. And then you have occupation, which is an integer, because occupation, again, that's surprising because it should be a string. So this is basically the data analysis that you will have to do, because eventually analysis will require you to have numerical data. You can't really do work around with text data or objects as it's called here in terms of in terms of the data type, but you will have to have integers that you can work with. I mean, not necessarily integers, but at least ideally it should be integers. So there's another thing which is also numerical, which is called float, that can take decimal points. But like there you go, there's float here as well. So it will either have to be integers or floats. So there's marital status and product categories, so the different data types are here. Okay. You also know how much memory has been used. 50 MB is actually quite a lot of memory. So 55,000 data points, that's quite a lot, right? So therefore, there's quite a bit of memory usage for just a simple Excel file, just a few columns. So now we are plotting the the null value. So we have to do, this is basically a very early stage analysis that you have to run on any data set. You will have to find out the null values. Okay, null values simply mean that you don't have any value for that row in that particular column. So there you go, in ends. So this will have to be found out, and as you can see that there are quite a few null values here in a couple of columns. So product category and product category 3, they actually have a lot of null values, as you can see from this distribution. So this gives you a nice visual idea. The reason why this has been done in this format, this is called a heat map. So the heat map, as you can see, is just a scale, and it just shows that the darker it is, it means that there are no null values, and the lighter it is, the shade that is, the lighter the shade, the higher the null values in it. So product category 3 and product category 2 is where most of the lighter shade exists, which means that that is where the the large percentage of null values exist. So now we actually go on. So this is an improvisation that I had to make, because I was trying to find out the number of null values in these two categories, and actually can see. So one thing that I did not mention. So how many entries are there? So these are the number of rows, right? So I just showed you how many rows are there in total, right? So that number of entries will actually equal there. So 55,069. So obviously one was one was containing the headings for each of the rows, for each of the columns rather, and so that's what it is. So 55,068 entries. So out of that, as you can see, a very large percentage here in product category 2 and 3 have null values. This is not multiple products, but this is rather what category layering that they belong to, right? So if it's a particular category, then you have a subcategory and then another subcategory. So that's what it refers to. So that's what it means. It doesn't mean multiple transactions. So now you can see the number of unique values in the data set. So this is how you do it. You see how much how many unique values are existing. So makes sense. Gender has only 2 unique values. Then you can see that age has 7 unique values, and that is because it has been done in classes, right? That's how it works. You'll see that we have to change that. We'll just see in a moment. And so a lot of different categories are there for each of these values, and occupation has 21. Okay, and we saw that occupation has been given in the form of a number. Okay, so it depends on the data set, what is the nature of the data types in each of the columns, and you will have to sort of rework that and make it usable for your analysis. So this is a description, and description means basically descriptive statistics, which gives you some of the central tendencies and dispersions, basic things like standard deviation, minimum value, and maximum value, and the quartiles basically for each of the values. Okay, so you can see minimum value of purchase is as low as 12, but the maximum goes on to was almost nearly 24,000. Okay, so the AOV range is pretty high in this data set. Most of the values are actually clustered. Most of the purchases are actually clustered around the values between 5,000 and 10,000, as you can see, right? So this is basically, you can actually imagine a normal distribution. So a normal distribution is a bell-shaped curve, and that actually gives you the central part of it, around the middle is basically where the highest frequency lies, and there's where the median and the mode will be, and you can actually imagine a normal distribution like this, right? So that's basically what this distribution approaches gives you. Now you can also check out the outliers, okay? And by the way, if you're thinking all of this analysis is useless, that's not the case. You'll see every step is actually important, right? It gives you an idea that, okay, this is the area that I should be focusing on. And outliers, for instance, gives you extreme values, okay? And you need to take care of outliers. There are multiple ways of taking, and by taking care, I mean accounting for them, because just have a simple example. If you are taking the average of 10, 5, and 100, um, or rather say you're taking an average of say 5, 5, and 100, it will be very high, right? Because it's 55, right? 10 plus 100 divided by 2, divided by 3 actually. So that's how much? So 110 by 3 is 37 almost, and you can see that it's very high, right? But you have two values which are 5, so one value can severely skew the results. I mean, this analogy has to be extended with more values, and then you will understand that if you have higher values, then it tends to skew the results, and that's why outliers are so important. You will have to deal with them, and that is what we are doing here. So this is basically called a box plot, right? So box plot is giving us a distribution of the purchase values, and as you can see that you know this actually represents this bar in the middle, this line that goes in the middle. This is called a median, and you have the interquartile range that actually lies here. Okay, and you will also have the upper value of the interquartile, using the interquartile range, and the lower limit of this box plot, which are given by these two lines. So the upper one is given by this. As you can see, nothing's below this lower line, and that's why the lower one has not been calculated. So it's all logical why it's been done in this way. Let's look at how the different values, the different columns or the different variables, potential variables, are related to one another. And the best way to do that is through correlation analysis, right? So correlation analysis can be done using, again, a heat map. We saw a heat map for null values just a while back. This is basically for correlation. Okay. Now, correlation gives you a very nice understanding of how the different variables are linked to one another. Okay. And this is an analysis which is so fundamental. This is not something that I see marketers do at a regular level, but they should be doing this. Because without doing this, you will not have even a fundamental understanding of how they're actually related. You probably just look at data, okay, I see this as reason, I see this has gone down, but this is not a good analysis because this is not based on any statistical or mathematical foundations. This is just guesswork. Okay, so don't rely on guesswork. Always try to rely on sound statistical strategies like this. So the heat map gives you an understanding of how they are correlated to different variables, as you can see. So user ID has been used here because it's only going for numeric values, as you can see. Some of the other ones have been dropped, as you can see. For instance, age and gender have been dropped because they were not numeric, right? If you go back to the kind of values, the data types that were existing, you'll see that these are objects. So the objects have been dropped. It's only going to go for the numeric values. By the way, the reason I've deliberately kept an error here is because I just wanted to show that the existing code where I had found it, this was not working. So I had to improvise because it was trying to convert a string to float. Okay, for a particular. I think this is the product ID. Okay, so sometimes it doesn't work. You will have to, when it doesn't work, you will have to find out ways and sort of tweak the code. So this is what I had to do. I had to use this little trick here, selecting the data types and converting all of them, and basically creating a new variable here with all the numerical variables. So user ID is also one of them, but user ID is actually not going to be very useful, okay, because user ID is not meaningful, right? It has no contextual utility. But it's there because it's a numerical value. I didn't drop it. We could have dropped it and also done the heat map. Actually, that's something you can do. But as you can see in the diagonal part here, all of these are ones, right? And that's because if you look at the diagonals, how they're constructed, so you will have to read it in this way, right? So you take the column and you take the row, column and row rather, and then just wherever the meet, that's the point that you should be looking at. Okay. So it's essentially like a simple graph, like x-axis and y-axis. So ones are where you will have the same value on both x-axis and y-axis, right? So naturally, you will have a correlation. You will always have correlation of 1 with yourself. And then for the rest of the ones, you will have to use the scale to understand the level of correlation. The lower is the correlation, the darker it is, and if the shade is lighter, it's closer to 1. Okay. So you can see that some of these correlations are very weak. So product category 2 and so product category 1 and purchase, for instance. So you should be looking at the correlations with purchase because this, of course, is your most important outcome metric, right? I mean, this is your outcome metric, so it's most important. So you'll see that these darker ones actually give an idea that, okay, these are not really very strongly correlated. Product category 1 and 2 are not very correlated to purchase. Apparently, product category 3 is correlated, but in a negative way. Okay. So the subplot is basically a way to have multiple plots within the same chart region, but in this case, we only have the pie chart. So that's what we're plotting here. So the way the pie chart has been done is using something called an explode parameter. Again, not something that you really need to dive into details, but just want to tell you how this is being done. You can just show the pie chart in a useful way. You have some of these built-in functionalities in Google Sheets and Excel as well, but this is just being done in Python. So it just shows one of those segments that you've defined in a separate fashion. So the female has been sort of shown separately from the rest of the pie chart. So that's what we are doing with age as well. So we see the same numbers here. Male is more, 26 to 35, the numbers are more. In terms of occupation, so the names of the occupation are not given here, probably because of privacy reasons in this data set. You have just different numbers for the different occupations. As you can see, 0 and 4, these occupations, whatever corresponds to 0 and 4, they have the highest number of people in the data set. So now let's look at data pre-processing. And data pre-processing is where you try to understand what you have to do in order to get the data ready for processing, right? So far we have been trying to understand the data set, and this was a very elementary analysis. Now we are in a position to actually start building the model, but before we do that, it has to be made ready for analysis, okay, for further analysis, for machine learning, for instance. So now we're going to do certain things. So like I was saying, you will have to make the data set ready for machine learning, and for that it always has to go for numerical values. And that's why we have replaced in the gender column, we have replaced anything that has a value of f with 0 and anything that has a value of m with 1. Okay, so this is in a sense called one hot encoding, where it's a binary classification and it's only either 0 or 1 in the data set. Similarly, if it's 4 plus number of years staying in a current city, that's been replaced with 4. Okay, and the data type has been changed to 64. Similarly, you can see with gender, with staying current city, the number of years, all of these are being converted into in 64. They were all objects before. Okay, so the data type has to be changed into integers. And we are also, like I said, remember in the age column, I said that there are actually going to be brackets, that there are classes. The way this data set has been created, you have to convert that into individual values. So these, each of these classes actually have the highest ending points as the newly chosen values for the individual classes. So the product ID and the product category. For the product category, you have the missing values, so we are filling them up with 0. That's what this code does. And there's for the product ID also, we are basically replacing a part of the string that starts with P00, and we are just replacing it with blanks. Okay, let's actually look at a product ID. So we are just taking these numbers, right? That's essentially what it is doing. Okay, the first P00, which is common to everything, that has been taken out. Okay. Great. So let's now jump into the rest of the analysis. We now have a correlation data frame. Okay, a correlation data frame is essentially trying to understand the correlation of each of these values with respect to purchase. Okay, so do understand that we have to find a correlation of each of these values with respect to purchase. Remember what we already saw, that product category 1 and 3, they have more correlation. We can drop marital status, and then we can drop CTA. City B we can drop, because city A and C can be better represented without it. Okay. So this is basically trying to find out the correlations with each of the different variables, and then selecting which ones to choose. So this is basically called feature selection. Now this is a very simple method through which this has been done. You can actually do it through multiple methods. We can talk about that in a separate session probably. If you are interested in knowing that, you can either look it up or you can let me know if you are interested. We can do feature selection. So which of the features are important is very important to understand. In this case, what we have done is try to find out the correlation of each of these variables with respect to purchase, because purchase is what we are going to look at. So the sorting has been done using descending. So ascending and defaults means this is in descending order. As you can see, it's decreasing. We have dropped marital status and city B, like we already discussed here. And now we're going to move on to scaling the data. Okay. Now scaling the data means that you're trying to transform the data in a way which is usable, and this means that different columns, different variables will have different ranges of values, right? Now you cannot actually run correlation or regression on any kind of advanced analysis. We're going to use basically decision trees here. We're going to use something called random forest. Okay, so XGBoost is basically using a tree. It's a tree-based mechanism that's going to be used. Okay, the regression that's going to be used for it, and tree-based, whichever most of the models will require you to have the data in a scale format. Okay, so scaling does precisely that. It gets all the columns in a similar sort of range so that they're comparable, and therefore the analysis is not harmed, or it's not impacted by the differences in scales. So that is taking one uncertainty away from the analysis, essentially. Now comes an interesting thing, and it's important for any kind of regression analysis. As I just showed you a moment back, we are going to do a regression using something called XGBoost. That's basically a boost. That's kind of algorithm. I'll not go into the deep of the deep analysis of what XGBoost stands for, but essentially it's going to be using the regressor model or the regression. Now in regression, you can have something called multicollinearity. So what is multicollinearity? It means that the variables that we call as independent, they can actually be dependent on one another. Okay, so the assumption of independence. So in our case, if you look at our data set, all of these things, obviously user ID doesn't make sense, as I've spoken about earlier. Everything apart from purchase is a potential independent variable, right? We have also seen that a couple of these are not very useful through feature selection process using correlation. But most of these are available as independent variables, but the assumption is that they're independent. Are they really independent or not? That is what multi-collinearity analysis does. That's what a mouthful, I know, but that's how it's called, unfortunately. So if they have some sort of dependence, then you have to figure that out, and that you can do using something called the variance inflation factor. And as you can see, that there are no variables greater than 10. Okay, when it comes to VIF. So that means in the feature selection process, we did one thing already. We saw correlation. The second step is VIF. There can be other things also, right? But we are only focusing on the most important things here. So there's no significant multicollinearity that exists in the data set, which is a good sign, meaning that we can keep all of these for analysis. Now comes our actual core machine learning model. This is going to give you the real prediction. And this is now going to be split into something called a. So there are two kinds of things that you have to do. First of all, you will have to create a Y column, which is going to have purchase, right? Like I said at the start, we're going to predict purchase, okay, the value associated with purchases, and that has been put into the Y column. The X column is going to have the other input values. Then we're also going to do a train test split. So this basically means that part of your data set is going to be used for training, and the rest is going to be used for testing. Okay, so training has 85% of the data set, as you can see here, and testing is going to have 15% of the data set. So this is how this has been done. Now comes the actual core model, which is the XGBoost model. That's what it's called. XGBoost is a boosting algorithm. It basically boosts regular algorithms like random forest or decision trees. Once again, this is not a core data science training class. We are not going to jump into the details of it, but XGBoost is considered to be very high performance, high performance machine learning model, which is useful in cases like this where you don't have a very clear idea about what's going to be the best sort of predictor, where you have multiple types of predictors. So it's a good ensemble model essentially. Okay. So XGBoost is going to import XGB regressor. Now, XGBoost can have both a classification as well as a regression approach. Machine learning typically has two approaches. One is classification and one is regression. And in our case, of course, we are doing regression analysis, and that's why it's XGB regressor that we're using. The other things that you're seeing within this bracket here are called hyperparameters. Hyperparameters are the factors that are defining how the model will work. Okay, how many iterations are going to be done essentially is what 1000 stands for. The higher this number, the longer this is going to take, by the way. Okay, this is going to take a while to run on your system, and the other things that you're going to that you are looking at here, I would suggest that you go for the values that have been provided here already. But this system is actually going to do a lot of hyperparameter tuning. You can actually go for hyperparameter tuning as well separately, but this has not been done in this particular code. Okay, so I've kept it relatively simple. If I had included that part, that would have been much more complex, and I would have actually had to explain how you're going to do that. Hyperparameter tuning can be done in multiple ways as well. Using some aspects of Python code, but there's also data science concepts involved in that. So I'm not jumping into that part. So this is XGBoost model for you, and you will also have the different predictions as well. So for instance, you have R square value that you will have to calculate. So this is basically an accuracy measure. You will have to. It's not just for running a model, right? You will have to have a measure of accuracy of the model. So how do you have an accuracy measure? So this is how you can do that. So an R square value is defined in the scikit-learn, which is basically the model that we're using, the library that we're using. As you can see, sklearn, scikit-learn.metrics. That's where from where we have loaded R to score. And R square is a very, very basic regression analysis score. And the way it works is you take the true value first and then the predicted value. Okay. And its best possible score is 1. And it can be negative if it is terrible model, if it's a very poor explanation. So it's basically an explanatory measure, meaning that it gives you an idea of how well the model is able to predict using the predictors that you're using. Okay, so the closer it is to 100% of 1, the better it is. Okay, so once the prediction has been done, as you can see, 74%, which is decent. It's not very bad, it's not very good, but it's reasonable. And once again, how it is doing that? It's doing because it's the auto score, as you can see, is comparing the prediction and the prediction using the y-test values. Okay, the x-test values rather. Okay, so it's basically using the x-test values, and then it's predicting using the x-test values, because as you can see, the total data set obviously has the feature values and the outcome values, right? You already have the data set. You are not splitting out that existing data set. You're not putting in new values into the system, but you are basically trying to understand from that existing data set. And that 15% that you did here, the split, that has both the the test part, that has both the features as well as the outcomes, right? So you use the features and from that test part of the split, and then you try to predict what's going to be the outcome values. That is basically going to give you the prediction, and then you compare the y-test and the prediction. And as you can see here, we are also trying to get, so we are basically creating a new data frame here, which is called y underscore df. We are putting in the purchase column within it, and we are creating another column called predict, having all the predictions. Okay, So there you go, another data frame here, and we are looking at the last few values. That's what .tail does. So the last 5 values, just like we had .tail, gives you the first 5 values. So purchase and predict, the 2 columns, and the values for each of these have been given here for the different product IDs. Remember, we had truncated them by removing the P00, but these are the ones. So the last 5,50,067 is the last one, right? So once you have that, you'll see that in this case, it may not be the case in your data set, but in this data set, you'll see that there are some negative values, right? Now, creating boosting models can actually return values inside and outside of the training range, okay? And therefore, a model has predicted some negative values. So negative values are possible, okay, in XGBoost or other grading boosting models. And so now we actually need to convert the negative values into 0. Okay, and how do we do that? Whenever we have a negative value predict, whenever it is less than 0, let's just put it to 0. Okay, because it's not adding any value, right? A negative value does not give any additional information to the machine learning model. It might as well be 0. So that's why we have converted these into 0 right now. You can just see, we are just look at the same data frame again. So data frame is like a table, by the way, in the context of Python. That's all you really need to know at this point. And therefore, we are pretty much at the end here. Okay? So now we have the real versus predicted values. We're just plotting it, and it's going to be a simple plot, but it's using something called a GG plot. Okay, and it's within PLT. PLT is basically matplotlib. Okay, an instance of matplotlib. So therefore, or in fact, pyplot within matplotlib, I should say. And you're defining the size. You're saying, okay, what are the columns that I should be taking, and there you go. That's all you're taking. So it's basically taking from the start to 40, okay, and the purchase and the predict, they have been plotted together. Okay, one is in blue, one is in red. So real values are in blue, and the predicted values are in red. And so that's how you can customize each of these things. But honestly, you don't really need to. So this is the ultimate graph. Okay, so this is a forecast. This is what we were looking for, and as you can see, it's not very bad, right? I mean, the blue and the red lines are almost overlapping with one another. And there are obviously some gaps here. As you can see, there are places where the prediction is a little off, but overall, this is a pretty decent prediction. And so how to use it, right? You will be able to use it. You will have to apply this model in your case and see how the prediction is coming out to be. You'll have to look at R2 score, okay? And if it is still good, then you can use it for your own purposes. You can upload future data, and you can use this model to analyze what will be the level of purchase. And depending on that, you can actually take your marketing decisions, right? So in this case, like I said, what is the kind of input that will be taken in by the system? That is product ID, gender, age, occupation, city, how long they've been staying in the city, marital status, and product category in their subcategories. So these are the input values, and I think these are very, very pertinent values when it comes to users. So if you have a separate user base, or if you have a profile of traffic that has been coming up lately, and you have information of this type, then you can actually upload it into this model, and you can run a prediction. Okay, this is one kind of prediction, this is one kind of forecasting, and I think this is a very powerful way of doing forecasting for Black Friday. There can be other ways. You can actually look at intermediate metrics as well and see the correlation and maybe even regression analysis, maybe additions to cart or maybe website visit related metrics, and then actually do a correlation as well or regression analysis, and you can do a forecasting with that as well. But I think this is much more powerful because this is based on actual users, okay, intent of users, their back, which is given by the purchases obviously that they're making, and it's also related to their features, right? I mean, what are the characteristics of users? That ultimately determines whether or not they're going to make a purchase. So I think this is a very powerful analysis. The only thing is that you need to have this sort of a data set. You'll have to plan. You'll have to strategize. If you need help doing that, just to let me know or just comment. I can give ideas. But once you're able to gather this type of data, you will be able to run the model and make predictions. So I hope this was useful. I know this was a longish video, but this should be useful for your Black Friday analysis. You get in touch with me if you need further help. But that's it for now. Like, share, and subscribe as always, and I'll see you in the next video. Thanks for watching.